Okay, folks, we're gonna jump right into lightning talks. If you remember, while we asked you to apply or submit your application, we also asked a bunch of you to submit these good 5-minute talks. So we've shortlisted and we have like almost 8 speakers lined up today. May I request all of the lightning talk speakers to please sort of occupy the front seat so that I can call you out in order. While you do that, I will just give a quick recap of the instructions. Each speaker gets 5 minutes to talk. We will be holding these, timing signs so that you know how much time you have left. We will hold up one that says 1 minute. We have another one for 30 seconds and then it's stop. And if you still keep on going, audience, that is where you come in. We're gonna ask you to clap as loud as you can so that our speaker knows that they've done their job, they've gotten their message across. So that is it for the lightning talk instructions. Our first speaker for today is going to be Thiyaku. Thiyaku, can we have you come up? So just to quickly introduce Thiyaku, Thiyaku has been working on the agriculture and water resources domain for 6+ years with the help of remote sensing data. He works for an organization called Satyukt, and he works on estimating soil moisture using SAR data, fusion of multi-satellite data, crop classification, and automation of workflows using Python and R. And today he's going to talk about Sat to Farm. So Thiyaku, I'm just going to switch to your slides. If you want to operate your slide, you can just press the button.
Yeah, good afternoon, everyone. Myself, Thiyaku from Satyuk. So today I'm going to talk about a mobile application which is called Sat to Farm, which we have created in the aim to give precision farming for all farmers. So if you see the farming, most of you may know, but just I'm covering it, what are the major problems which the farming society is facing. One is like, mainly it's due to the lack of information. Maybe we don't know what is the soil health of the farm, so the farmer may be using excess fertilizer, or we don't know what is the pest or disease. The farmer is buying the pesticide or the pesticide which is recommended by the local markets, or maybe then he has to keep on try and then something, or maybe the supply chain issues where there is a not nearby markets, or there may be like there is no way. So there is the logistic issues or something, and then if you want to take a loan, again the data is a problem. If you want to take a loan, if the bank not having the data at the right time, they can't give the loan at the right time. And again the insurance, if the farmer wants to claim for the insurance, if there is the loss information nowadays involves a lot of manual work which takes lots of time to come. By the time he gets the insurance money, he has to pay back the loan or something, then again the farmer is going to suffer. So we are aiming to solve this problem. We are having many products. With that, one of the products is Sat to Farm. There is a mobile and web-based application. So in this, what we are doing is we are providing information using the satellite data. So there is no need of any hardware to be installed, and we provide the information at the 10-meter resolution. Everybody knows we are using the Sentinel-1 and Sentinel-2 satellite data to provide the information at 10 meter. And then we are providing the crop water management solutions for the irrigation advisories, and also like how much to irrigate for a particular crop, and maybe how much optimal water is required, whether the crop require water or not, and also the crop health management. Like if there is any pest or disease, we say there is a farm is undergoing the stress, and the farmer can upload their photos to our app, and our agro experts will provide the solution, what chemicals to be used. And also like we provide the satellite-based soil nutrient estimation like NPK, soil organic carbon, and pH macronutrients estimation. And again, we provide the recommendations based on that, like how much the fertilizer to be used and what dosage they have used for either basal dose or the top dressing. And then the weather forecasting, we provide the information through that the farmer may know like when they can do the pesticides, or when they can go for spraying, or if there is a rain probability, whether they have to postpone their activities or they have to prepone either the harvesting things, those kind of activities. So this we are providing it via the API also. So if somebody wants to integrate it their app, which they provide, so we have providing the API, so they can take that API and plug into their apps. So how we are doing it? We are doing it, a lot of things are involved. One of the major thing we are using is Google Earth Engine. As earlier we were downloading the data into our local system and it's taking lots of time. So the Google Earth Engine, as all knows, it has a petabytes of data. We have a GCP which is in our system. So when the farmer has to geotag their farm boundary, like you are seeing in the screen, once the farm boundary we have a Python code which uses the Google Earth Engine to fetch the data and deliver the data through the front end. For this, we are using other cloud services also. So most of the things we are using in the GE and GCP is like for sowing and the harvesting data identification, crop classification, and multiple things. So these are some few snapshots of how the application is. First is the login page, and the user can choose what are the languages they have. Either they can walk or draw the form boundaries, and then they can give the information. Once all the informations are came, we give the information like crop health, soil moisture, the time series of the data, weather forecast, and then irrigation advisories, and also the crop nutrients and the water spread area also, if they can map the water bodies. Yeah, we have currently 30,000 farmers. Yeah, thank you everyone.
Our next speakers are Ujaval Gandhi and Ellen Brock. Ellen Brock is from Belgium, residing in India since 2004. She has a PhD in econometrics and is self-taught on remote sensing. She has work experience across academia, multinational companies, 3 startups, and currently is a consultant data scientist at Mantle Labs. Ujaval is an ex-Googler who worked at Google for 15 years on Google Earth Maps and Earth Engine. He left Google in 2020 to work on a startup, Spatial Thoughts, where he's building a learning platform for modern geospatial technologies. His open source learning materials are used by over 1 million people every year, almost as much as like a Google product. Over to you, Ujaval and Ellen.
All right. Hello, my name is Ujaval.
My name is Ellen.
And we both were involved in this new book project called Earth Engine Fundamentals and Application. I was a co-author for a few chapters, and Ellen was the lead reviewer. She read every chapter of the book from start to end and reviewed it. So we're going to talk about this book. What is this book? This is a project that kind of conceived during pandemic, and multiple people came together to produce an open and free learning resource in a book form. And currently the book lives as a web product, which you can go. It's openly accessible, 55 chapters, covering both fundamentals and applications, all driven by volunteer authors. And this currently it's available. It was launched at Geo for Good. You can visit this URL, eefabook.org, and read the book, access the entire book. It has got a code repository, which is a fully reviewed code. We also had a team from Springer involved. It was professionally copy edited and is going to be published as a citable publication by Springer, which you can access later this year. Who worked on it? These are the editors led by Professor Jeff Cardell, along with Morgan and Dave Sa. Nick Clinton from Google was involved. He reviewed all the code that was written and ensured that it's consistent and matches the Google style. And again, there were many experts and practitioners of Earth Engine that came together as volunteers to author different chapters. I authored 3 chapters. We have folks in the room. Madhu also authored a chapter. And those chapters were then put together. It was reviewed by many volunteer reviewers who ensured that the chapters were consistent and met the quality standards. So as a learner, you are able to work through the chapters consistently. I want to hand over to Ellen to talk about the content of the book.
Thank you, Ujaval. So basically, this is the link for the book, and there are 2 parts of the book. One is the fundamentals, and a second part is the applications. So the fundamentals, if you really want to learn to code in Earth Engine, this is the first part. And then the applications, a lot of applications, too detailed to go all over them, but human applications, things like agriculture, heat islands, aquatic hydrological, river morphology is there, terrestrial applications. I think Madhu has chapter in this. So how to use the book? There are basically 5 different users that you can have. If you're an absolute beginner, you can start in the first chapter. Or if you know some remote sensing, you can start there as well, if you're from another coding background. If you're even new to remote sensing, I would say just give it a shot. It's definitely worth a try. And then there are other entry points. I'm not going to go into detail. The details are in the slides. So intermediate users, you have experienced users, very experienced users. You can use it as a lookup. Like you have a question, you can just do a search and do it. And then explorers, these are people who know Earth Engine very well, say, I know the basics, you just can go to the applications of the book. And there's also a repo of the book, so you can code along with the book, and this is also on the website. So lessons from the book review. First of all, I would like to thank the editors, authors, copy editors, or the reviewers. Why did I sign up for this? Well, I just wanted to dig a little deeper in Google Earth and remote sensing. And I said, okay, I'm going to do just 16 chapters, so you could choose. But the learning, I kept on, my interest, I got a lot of interest in the book, so I kept reading it and eventually read the whole book. Another thing, thoroughness was very critical to do it, but at the same time, you need a lot of iterations, you have deadlines as well. So why we all need your help, please do have a look at the book. It's a living book. There are Earth Engine updates, code changes, external dependencies are there. There might also be errors in there, and more eyes the better. And you can, you don't need to finish the fundamentals and go to the applications part. Pass it on.
How to contribute? You can, of course, review a chapter and provide feedback. That's really important to catch any errors. If you want to translate it, there's a way to sign up and translate this book into your language. And we have, go to the book. If you remember only one link, eefabook.org. All the information is there. We're also going to do a live video walkthroughs of the chapters where you can join live users and learn from the authors. So thank you.
Our next speaker is Surajit Ghosh. Just gonna... It's fine. You can just go to here. You can just go like this. Yeah, yeah, it's fine. You can just scroll down. So just a quick introduction on Surajit. Surajit is an experienced researcher with a demonstrated history of working in the environmental services industry, mainly applications of remote sensing and GIS in forestry, water resources, and agriculture. He's skilled in MATLAB, Python, LiDAR, and radar altimetry, data processing, machine learning, spatial analysis, and big data analytics. He's also experienced in hydrological and ecological modeling. Over to you, Surajit.
Thank you. So myself, Surajit, I'm from IMI, International Water Management Institute. Basically, we work for research, but not only research for development. So whatever we do, that should have some field impact. Field impact means last man should be benefited in somehow. So 2019, I was in a similar event here, and we start the discussion on how we can work on the water-related disaster, how we can manage and mitigate. So we got some help from Devaja and others, Google colleague. We got some Google Asset Space and all this, and we started development. One of the platform, I can say, SADMS, South Asia Drought Monitoring System. So what is the South Asia Drought Monitoring System? You can go, this is a particular link, you can see how the system works. So this is how we can monitor drought, how we can take the early action if there is any drought in progression. So drought is not to say instantaneous event. It is some indication in, let's say, sometimes in 1 month or 2 months in advance. So that process we have implemented, and here it is not only data, we talk about evidence, we talk about how policy can also respond here, and basically the feedback from this system, how can this help the decision makers at the district level, I mean to say. And here we have launched last August with the help of SARC Disaster Center in Gujarat. So let's go for the technical side, whatever we have done here. So this is, we have different, for other system, we have to go with different kind of technology. that are involved here. User can choose their particular indicators or particular area to see what is the present condition of different models coming from weather model to drought management, contingency plan. So contingency plan is a kind of early action. If you are seeing something is happening from the indicator level, that what could be the possible action. So you can mitigate in-season drought. It's not that drought already happened, then you are going to field or you are taking action. So in-season issue you can handle, and you can generate online bulletin also from there. So those whatever we talked about, much more on the data sides. So if we can see that we can get the weather and climate monitor as a submodel, from where we can get some kind of, let's say from 7 days weather prediction to seasonal or sub-seasonal weather prediction. So we can get some kind of information. We have a model, it's called VIC. We run there in the system and get the output, what is the issue is going to for next 15 days. Then we have a drought monitoring. There is around 40 indicators involved in different submodel to address those specific issues. And the heart of this system is a drought decision support tool. So we have a NDMA, this National Drought Monitoring Agency. So they have some guidelines. They have some policy. So how we can implement those things here? So it is not to follow or not to need to generate the maps separately. You can go there in the system. You can get the not only pixel level data, you can get the aggregation at your district level as well as state level. So those things are there, and based on that you can take some kind of early actions. So yes, so as I told, this is one example, but we're also working in some other platform also, like South Asia Drought Monitoring System. We have developed this Earth observation data for agriculture insurance platform. That is again our impact up to the farmer levels. That's EO for AY for Sri Lanka. We have GeoGovia. Govia is a Singhali name of farmer. So it's a geo farmer, let's say. So we are taking data at the farm level, and some kind of compensation is giving based on the government policy. And right now we are working on some initiative at the CGR level, and this is called Aware. Agrise is another application. Every year we are basically using, I can say 60 to 70% Google Earth Engine data and all this. So that's all from my side. Thanks for your.
Thank you, Surajit. Okay, our next speaker is R. Nagarajan. Nagarajan is a scientist specializing in GIS and remote sensing at MS Swaminathan Research Foundation, Chennai, with over 18 years of experience in the application of NRM, agriculture, biodiversity, and climate change. He was part of the Google Maps team at Hyderabad, and his research interests are modeling and quantification of carbon stock using remote sensing to support the national NDC goals and UNFCCC RED Plus for climate change and mitigation. Just gonna present. And over to you.
Thank you, Devja. Good afternoon, all. I'll be presenting how the Landsat satellite images can be used for mapping mangroves. So you all know that we have a wonderful Landsat ArcViews images, almost 50 years of satellite images we have. That's the only satellite images is available for the change direction analysis part actually. So how effectively we can use this for mangrove mapping actually. So you all know that mangroves, yeah. So as you see in the picture, this is mangroves actually. So mangroves is a diverse crops, saline tolerant crops, which we can find in the estuary part. So how it is useful? It is considered one of the climate change, so one of the nature-based solution for the climate change, and it has a very good ecological as well as economical importance in the world, and where the mangroves can be found in almost 124 countries along the tropics actually. So that's a special location where you can find only the mangroves actually. So these are some of the ecosystem services. So it is estimated that mangrove ecosystem service is almost $800 billion per year, and it's also the climate change regulation where it stores almost 5 times higher carbon than the tropical forest actually. And fisheries also, it's almost 3,000 fish species has been found in the mangrove ecosystem itself, and of course the tourism as well as some coastal protection. So mangroves is considered as a bioshield where during the tsunamis and cyclones, it absorbs most of the cyclone storms as well as heavy storms also. So that's how the mangrove ecosystems are very useful for the fishing communities also as well. So this is my study area, what we are doing in the Pichavaram mangroves, which is the second largest mangroves in the Tamil Nadu, where it is highly useful for the conservation purpose. So why we studied this one is particularly, that mangrove ecosystem, as you see in the image, it is really difficult to go into the mangrove ecosystem. Actually, it is fully muddy in nature, and it's very difficult to do survey also actually. So we extensively use remote sensing, and thanks to the remote sensing also, so we got a very good satellite images to just study the health of the mangroves and the spatial extent how much mangrove has been grown in that area. So MS Swaminathan Research Foundation is specifically working on the restoration of mangroves. So we do restoration of mangroves in collaboration with the government forest department. And by the way, we just restore the mangroves. So how to quantify the mangroves? So we got a problem that's saying that if we restore so much of mangroves, we need to report that how much mangrove has been restored and what are the areas still can be restored actually. So we use remote sensing for that purpose. Particularly for this study, we used Google Earth Engine. So I used almost 40 years of satellite images. This is the methodology we used. So since 1977 images we don't have in the Google Earth Engine. We just ingested 1977 Google Earth, Landsat satellite image in the Google Earth Engine platform. And the wonderful tool that's called composite cloud removal. This is a wonderful tool by the GE where I can get 1 year composite cloud-free satellite image. As a remote sensing guys, we know how it's difficult to get a cloud-free images. So from this particular algorithm, we can easily get a 1 year of cloud-free satellite images. And based on that, we did a random sample classifier we used here. And we calculated the gain and loss of the mangroves in that particular reserve forest. So these are the analysis we carried. And this is a snapshot of the maps. So where you can see the 1977, how the green patches, what you're seeing on the screen is mangrove extent. And after the conservation effort started by the government of India as well as the government of Tamil Nadu, slowly the mangrove area has been increased over the period of time. So as you can see in the image, how the area has been increased from 1977 to 2021. So by the remote sensing and the Google Earth Engine, it's easily we can easily quantify the area. And these are the area, how much area has been changed. And also we analyze the change direction also in the Google Earth Engine platform, where we can see almost 624 hectares of area mangrove has been restored in that particular reserve forest itself. And my conclusion is like we all know that if you want to process the images, we need more sophisticated software like ERDOS or whatever the RGS. But using this Google Earth Engine, we can easily pre-process all this images, and we can quantify this one. And one thing is like we can easily replicate this model to any other ecosystem where we can use it for carbon credits for programs and other things. And the future studies, what we're planning to do is like Moni, the presenter shows, we can use GDI data and Pulsar data to quantify the mangrove carbon stock. That's our future study. Thank you very much.
All of you already know Ujjaval, so I won't introduce him. But he's here to talk about the Earth Engine Community Catalog. So over to you, Ujjaval.
Hello everyone. Raise your hands if you are Earth Engine user but not heard of Earth Engine Community Catalog. Okay, this 5 minutes is going to change your life. So in the morning, Simon talked about the main Earth Engine catalog. It's got a lot of these data sets, Landsat, Sentinel, all of this data set. But there is a community effort that puts in and makes available a lot of the other data sets, other public domain data sets that you may want to use in Earth Engine. This catalog started as a project by Sam and Erin. They wanted to take some research output that people have generated and make it more accessible. So Sam just started uploading this data to Earth Engine and making a front end to make it discoverable. And the project has grown considerably over the years, and it contains now a lot of data set. Over 100 terabytes of data sets, and a lot of the data sets that we do not find anywhere else, including a lot of the socioeconomic data that Simon told we wish was in the main catalog, but now it's available here. It also got data sets that Google may not be ingesting due to commercial reasons, but the communities will be able to do that. So you will find all of those data sets as well. There are a lot of different categories of data sets that you will find there. If you're a researcher trying to figure out what you want to do, have a look at this catalog, and you'll find data sets that might inspire you to figure out. Because a lot of times you may have a cool idea, but you may not have the data set to work with. Now you say, these are the data sets that are available to me, and now I can generate something on top of that. Let me just quickly show you what the catalog looked like. This catalog was recently moved to a new URL, GE-community catalog. Here, there is a section on getting started. There are some videos on how to use this, how to navigate it, how to contribute sources, how to report errors, and so on. But the main catalog is here. Data sets are organized by different categories. A lot of socioeconomic data that's available here. Landscan population is now available globally, one of the best population data sets that are there. There was a question about Microsoft's building footprints. Why are they not there? Well, it's here. This is the only platform where you can access all 1 billion building footprints at one place. And this data is simply so large that, if you want to download a subset, the only way to kind of currently do it is go to Earth Engine and subset it, because no other platform can handle this large data set. Each data set has an Earth Engine snippet, which you can just copy into your Earth Engine's codeator, and the data will just show up. There's also sample code. If you click here, you'll see the data loaded into Earth Engine. So that's really useful to see this. Other kind of data that you might be interested in is the elevation data. Getting a DEM for your region is typically pretty hard. There are a lot of DEMs available here in this dataset catalog, so you can check those out. My favorite are these global utilities and assets. So a lot of this vector data that you may want to have. Where are all the photovoltaic farms? You have the global database of that. Where are all the wind farms? There's a database for that. This UCLA released the speed test data. What is a speed test at every place in the world? Oh, and it's the time series data. So you may want to analyze that, and you have already access. Downloading and processing it, I actually ended up writing a tutorial, 5-page tutorial, how to download and process the data before I found that, I can just point people to this and they can directly use that. So do check out those data sets, and you can apply that. How to get involved? It's a community project, so everyone is invited. If you have your own data set that you are publicly available, that you have generated and you want to add to the catalog, you can go to the catalog. There's a section where you can send a request. If you just find a data set that you say, this is a great data set, I wish it was there in Earth Engine, you can file a request. Sam is usually very quick in doing this. I requested the Radiant Earth data set I found on Twitter. Oh, Radiant Earth released the labels. I pinged Sam on Twitter. Sam, can you ingest it? 2 days later, he said it's there. It's a very large data set here to pre-process and upload it, but it's there. If you found an error, please report this. The main thing that the community is now looking for is more robust code examples. If you end up using any of this data sets for a project, do submit your code example. So people know, oh, I have this UCLA speed test data. How can I do something interesting with it? And if you've done something interesting, do submit that code sample so people in the community can get involved. And this is the URL, gecommunitycatalog.org. Go visit and find your next awesome data set. Thank you.
What an awesome data set. Okay. So our next speaker is Anirudh. Anirudh is from Let's Be the Change. He's a social entrepreneur on a mission to #Clean India by transforming ISOs, inculcating sustainable habits towards adopting low waste lifestyle and building energy with local authorities. Synergy with local authorities. Over to you, Anirudh. You can just, yeah.
Yellugu Namaskara, very good afternoon to everyone here. My name is Anirudh. I run a non-profit called Let's Be the Change. So whenever we go out, the first thing we see is a civic issue around us. We would have noticed and we would be thinking, can we do something about this? Let me give an example. We work in the waste management space. So let me give an example that there is a garbage dump right in front of your own house, and your neighbors are walking to you, giving you a smile, hi, how are you doing? And then throws the garbage and walks out. So we try to figure out what can we do. You know, some days, yes, if we are really good, we can do a cleanup drive. We can tell our neighbors not to throw waste. And what is the next step? What do we do? What do we do, guys? Forget about it. Call BBMP, that's true. But whom do we call in BBMP? So that remains a question, where to report. Because most of us know that municipality, only we know it is the commissioner. Or else we know there's a Twitter account of the municipality, put it there and try to tackle the problem. But no, guys, India is known for the hierarchy system. India is known for the structure it has. So, okay, let's get back in understanding more. So we are an active citizen. So we go back to the website trying to identify, where the problem is and whom we have to, report this to. And then we also see huge PDFs which are being associated with each of the government websites, where you only see a lot of data and you finally don't know what to do with it and you end up, oh shit, just live this up. And if you are really one among those 0.001%, you'll be able to find your respective ward details, and then you will make a call and that guy doesn't answer the call and that's it, you're done. So what do we do about this? Can we make it as simple as, this, where kids are playing around? Can we make it as simple as this? Can we? Yes, guys, we definitely can. Google has really made it possible for us. This is nothing but using a simple tool. Again, I'm a non-coder, using a simple tool called as Google My Maps, wherein we have made such big, huge data being very, very useful and very handy, as simple as using a smartphone. Okay, let me tell you guys some of our user case. Starting from the COVID situation. So we mapped close to almost all COVID care centers across Karnataka in one single map, which again, if you click on it, everything would be saved on your Google Maps phone app itself. You don't have to do anything else. All you have to do is become a volunteer, help your friends when they needed help. So as simple as that. And then we also were really ambitious, but we really did it. We mapped it across India and we made sure all the COVID centers are mapped across the whole country. In the same way, we work on waste management space, like I said. So this is an urban poor settlement, a slum, wherein we try to improve waste management practices. So we divide the community and we use it in such a way that people understand what is waste management, and then we have different teams working in each of these spaces. If there are any questions, feel free to ask. And I have a request, if you are a non-coder or if you are a profitable or a non-profit organization and you want to work towards bringing a better impact using My Maps, please attend today's afternoon session, where I would love to explain more about our initiatives, how we are creating more impact using Google My Maps tool. Thank you. Any questions? We have time.
So we have solution for that garbage dump?
Yeah, we have. So you have to attend my session for that. So we have another minute. Feel free to ask questions. If not, thank you.
Does anyone have any questions? No? Okay. Thank you, Anirudh. And this is the G4G for non-coders track. Anirudh is doing a session on My Maps, so please do attend his session. Okay, our next speakers are Janhavi and Jyoti. They're going to be talking about application of Google mapping products and climate action plans. I think Raj also referenced the awesome work that these guys have been doing. You also saw that work in the video today morning, so we've come full circle. Janhavi has been working at WRI India Geoanalytics team on city-level climate action plans. She has a personal interest in remote sensing for mangroves in coastal urban areas. Jyoti was one of the student researchers in the Summer of Earth Engine program 2019 and currently working as a project associate at WRI India. She uses remote sensing and GIS techniques to analyze and map geospatial data to help government and non-government stakeholders make on-ground decisions. Okay. I'm gonna hand it over to Janhavi.
Thank you, Deja. Hi, everyone. So I'm here to talk about the climate action plan and how we have used the Google products, basically mapping products, Google Earth Engine and other things for this climate action plan. So just to give an idea, basically climate action plan talks about cities and the kind of climate hazards, risks that a particular city faces. It's sort of an evaluation of the city's preparedness, the population which lives within the city, how much of that population gets affected by these hazards that cities face. So these are some of the sections in the climate action plan. First of all, heat. In heat, we are considering the surface temperature and air temperature. Particularly this heat section, I'm going to come back to it in a bit of like more detail. Then air pollution. So as I mentioned, it's about how the cities respond. So mainly the government agencies are playing a huge role as stakeholders in this. So a lot of data particularly for air pollution, just an example. So comes from Pollution Control Board data, the monitoring station data sets. But these data sets have limitation in terms of their special expanse. So over here, the satellite-based data sets like Sentinel data sets come into the picture, and we use these data sets in the Google Earth Engine platform, process the data sets for monthly composites, yearly composites, to understand the changes within these concentration of these pollutants and how the plumes, etc. Then under urban vegetation, so within urban areas, we have monitored the change within the urban vegetation, and we have used the I-tree canopy tool to understand the carbon sequestration by these urban vegetation. Then in climate projections, we have been we have tried to understand the precipitation and thermal data. And then in case of topography, so basically in topography data we are dependent on DEMS, then the land use data sets. Basically these data sets help us to understand the flood related impacts and flood projections basically. Then the last section in this is access to services. In this, we basically were looking at locations or areas within the city which can have access to a basic service, that is a hospital or a fire station. But these were purely based on distances. So we went ahead and compared these service areas with the Google traffic datasets, just to understand how it will change with the traffic scenarios. As in, if I am saying that by house can be reached within hospitals, but it might not be the case at a peak traffic hour. Then, as I said earlier, so this is the heat section. In heat risk, we are looking at the air temperature, then the land surface temperature. So how land surface temperature depends and changes with the type of land use, then the vegetation that is available within that area, and the open spaces within the urban fabric. So basically that showed us that how the slum areas or low income areas where the houses are very close to each other, then the industrial areas where the roofing type is mainly used it uses tin or asbestos sheets, how that increases the land surface temperature. Yeah, thank you.
I think if you just want to conclude, you can take 10 seconds to just.
No, it's okay, it's fine. Yeah.
Next speaker is PRAKRUTH YADALAM. PRAKRUTH is a sociopreneur and founder of Dhirya Foundation. Dhirya is an NGO working towards making holistic education accessible. With an aim for an equitable society, PRAKRUTH and his team work closely with underprivileged children in shelter homes and government schools. Okay, over to you, PRAKRUTH.
Namaskara, good afternoon. I'm Prakruth and I'm a beginner in this space. From what I heard since the morning, I feel there's so much to take away from the experts who are here in this room. But as you see on the screen, this is the topic I'll be speaking about. It's completely different from the discussions we have had since the morning. So it's an insight into how we can relook education and the accessibility of education through geomapping. So I think the theme might look very idealistic and ambitious. I would like to just mention that we are in the beginning of this process. So in our NGO, we are trying to see how we can approach this in a bigger and a macro level initiative. And I'm very happy to have my friend Anirudh here, who we had worked together on one of the projects during COVID. And that was kind of an inspiration for me to take this forward and see how we can impact the education space. So just to start with a few numbers, so 2019-20 data for just Karnataka, it says that 82,000 students are out of school, meaning they dropped out of school in that one specific year. And when it comes to Bangalore, we might assume that Bangalore South is one of the most well-developed and renowned zones across different zones. But just in Bangalore South alone, we had close to around 18,000 students who had dropped out. And when it comes to education, we have a lot of talk about enrollment, teachers, and people, not having access. But we try to relook this in the way of how do you, look at this as a community at large? Because each of us are involved in this space in one or the other way. And one of the inspiration for this was the COVID time. Because during COVID, we saw how different stakeholders stepped in with different kinds of support. And we were actually shocked to see that many of them were willing to support, but they didn't know how to go about and do it. We had people who used to call us saying, I'm willing to say donate 20,000 rupees, but where do I donate? And to whom do I donate? And that is when one of the geomapping tools that we used was really helpful. So in the same way, during our process, so I've been in this space for the past 5 years, working with underprivileged kids. And we understood that many people, like be it software engineers or students, we have our weekends free. And most of us want to do something useful or beneficial for the society. And that is where we started a weekend volunteering program, where we started this concept of, dedicating, say, 3 to 4 hours on a weekend where you spend time with kids, be it in your neighborhood or in government schools or in orphanages, where these people don't have access or things like that. And getting to the second aspect of how we actually use this. So the main aspect is with respect to resources. So when it comes to education, there's always a talk about resources. And the assumption is there's lack of resource. But what we found out is it's not lack. It's the lack of interconnection between the existing resources. We have spaces, we have people, we have tools through which we can enable a brilliant revolution in the education space, which has not happened because there's a huge gap between the different stakeholders. And this is one specific use case. So here is where we try to map Bangalore into different zones. And through different layers, we understand how this can be useful in the coming days. Thank you. So this is a general ward map of the 198 wards that are there in Bangalore. And this is a mapping of government schools in one specific zone in northwest Bangalore. And the red parts, the red dots that you see, The red dots are basically the BDA complex. So the Bangalore Development Authority, they have these complexes in, I think, 8 to 9 zones in Bangalore. And this is like a huge space. It's like an epicenter of, say, different sort of public activity that happens, commercial and administrational. And then we try to map orphanages close to that zone. And when you actually zoom in, and the orange part that you see there is one of the low-income societies or like a neighborhood that is there. So just with this one mapping tool, which took us hardly any time, most of the data was already there, we could actually, we are trying to map out how we can we aim to create an app where any user, just like how you access Ola and Uber, you open an app and you see neighborhood schools and orphanages close to your place, and how you can immediately, make use of that space, either by donating time or knowledge or any sort of resource. And one actual use case was with the government. So in 2021, just after the first wave, we collaborated with the government to start this project called Doorstep School. How many of you have heard of this Doorstep School, School on Wheels? So we refurbished 10 old buses along with the BBMP, and these buses were supposed to act as schools. But later it didn't take off in the way we wanted to. I think if some of you have heard of this, you would have seen some buses lying vacant on the roads in different zones. So they just distributed the 10 buses across 10 different zones because it was so difficult for them to understand where does this bus go and function. So this is just an exercise, a mapping exercise that we had done of how it can actually be useful of getting data and actually figuring out zones where this bus can go and actually function as school, where there's an actual requirement. And yeah, this is one photo from that. And yes, thank you.
It is indeed refreshing to see an educational use case of, maps. It takes us back to our old days when we, started out with using Google Earth in classrooms in government schools to make social studies more fun. Okay, so we have our last speaker for today, Shiva Subramanya from HE. Shiva is an IT manager at HE with over 15 years of experience in managing geospatial data, developing geospatial applications, and training researchers, local communities in mobile data management and visualization.
Hello, everybody. Yeah. So the participatory mapping of alien invasive plants, it's a initiative that is basically it has been started with the aim of producing an atlas of invasive plants across piloted region of Tamil Nadu. So it's a citizen science driven initiative to measure the extent and scale of invasive alien vegetation across that region. So the initiative involves a rigorous grid-based sampling of data using citizen science groups or local communities. So basically so what it aims to address is some of the issues like, say, loss of biodiversity or increase in instances of forest fires, decreasing quality of livelihoods of local communities, and so on. So we have used, for data collection purpose, we have used the Open Data Kit suite of tools. And so we have divided the entire area into a 3-minute by 3-minute grid. And then, so in those grids, we have prioritized 2 transects, belt transects. Basically, if you know how there are different types of transects. So we have used the belt transect method. So there will be 2 belt transects for each grid. And then, and then using tools like Google Earth or things like that, Google Earth Engine. So we have tried to prioritize the transit identification and then prioritization, landscape assessments, and so on. So we have also tried to be as inclusive as possible in our process of data collection using, we have tried to involve or try to make local communities and then policymakers and other stakeholders participate in the process of data collection. Basically the advantage is that these people with their traditional knowledge of landscapes and species bring in a lot of value to the data that is being collected. So apart from that, you also have the additional value of how to mitigate from this invasive species spread. So the eventual outcomes of this project is one is apart from the data collection, we have developed a backend application using Google Maps, Leaflet, and then Postgres, and then other JavaScript based libraries. So where we not only manage the data that is being collected in real time, but also try to assess the socio-ecological impacts and then how they can be used for strategizing mitigation measures. So apart from that, you also can measure the prominence value of these invasive species that are present in these regions. So, and then apart from that, basically, so with those patterns, we eventually want to build an atlas of invasive species spread across this region. So that will probably help us in coming up with a better mitigation measures for invasive species, not only managing it, but mitigating it from that the spread of these species. So incentivize local indigenous communities to participate and minimize the impact of invasives on the quality of livelihoods through alternative supplementary sources. Thank you.
So that was it for all of our lightning talks.